Good morning, students. In this video, I'm going to talk about the various types of functions. In the earlier class, we discussed about the various types of random processes, and in this video, and I'm going to discuss about the various types of functions. Then, first function, I'm going with the first function is called it is a time average function. Time average function. So this from this we can expect the some long answer question and the short answer questions also, because all together all the functions together it will be a long answer question, and if they ask the separately that will be the short answer question. At least we can expect the 10 marks from this topic, so that you must be very careful about this particular topic. So that I am going time average function. Consider a random process x of t. We have the random process. Let x of t is a random process, and in which we will be choosing a sample function. It is a small x of t. X of t is a random process, whereas a small x of t is a sample function which exists for all the time at the fixed value in the given sample space of yes only. So that means what? For all the time, for all the t values, this x of t can be existed. The average value of x of t, the average value of x of t can be taken over all the times is called the time average of x of t. Simple thing, we have the random process, that is capital X of t, in which we will be picking up one random sample function, that is x of t. This can exist for all the values of t. Then the average of this sample function will be called as a time average function. So the average value of x of t taken over all the times is called the time average function of x of t. It is also called as the mean value of x of t, and it is denoted with the x bar, because if it is complete a random process, we can call it as capital X bar. In the various random processes, we have denoted this is with capital X bar, because we have calculated mean is for the total random process. Now we are not calculating the mean is for the total random process. We will be choosing a sample function from the random process. Sample function is what? X of t, for which we will be calculating the average value, that is called average function. X bar, small x bar is equals to average of x of t. A stands for average. Average of x of t is nothing but it is going to existed for the all the times. It is going to be existed for the all the instant of times which are continuous, so that we will be taking the integration, so that limit t tends to infinity. From minus infinity to plus infinity you can have t tends to infinity, means you can replace t by minus infinity, here t by plus infinity. 1 by 2t integral minus infinity to plus infinity x of t dt. So this is nothing but it is the sum only, it is a total sum only, which has been existing of x of t from minus t to plus t, and we will be dividing that by 2t, and that will be converted as a mean. Mean is nothing but what? It is the average only. What? It is a total sum by number of events, that will be called average. So that it is a total sum integral of x of t, and which will be existed from minus infinity to plus infinity by 2t. This is nothing but it is a time average function. Here you should remember the point is that if the capital X bar is there, that is nothing but it is an average or mean value of a random process. But here the small x bar is there. Small x bar is nothing but from that random process we have chosen one sample function. For that we will be calculating the mean value, average value, that is nothing but it is a time average function. The next one I am going with the next function, that is time autocorrelation function. We have to understand that time autocorrelation. Autocorrelation must be within the same random process, whereas cross correlation must be and between the two random process or two sample functions. So that here we will be having the two, here that autocorrelation is nothing but two samples are from the same random process. Two samples are from the same random process. See this one. Here we will be having, consider a random process x of t, capital X of t, it is a random process. The time average product, this is a time average product of x of t and x of t plus tau. That means what? It is the another sample. It is another sample which is chosen at the different time interval. That is what t plus tau. We are adding something so that this is at one time instant and this is at another time instant, and we are going to calculate the time autocorrelation function between these two. So that here we will be having, consider the random process x of t and the time average product of x of t, and x of time average product is nothing but this one, and time average product of this one. These two product will be called as, it is the time autocorrelation function. You know that it is autocorrelation, or x of tau, you can call it is a tau, and is equals to average of a product. This is x of t, and it is x of t comma x of t plus tau, and it is average product of x of t and x of t plus tau. It is called as time autocorrelation function. In other words, you can write that is about r x of tau is equals to limit t tends to infinity, and now this is a product we require to have 1 by t, and in place of x of t we have x of t, and the another sample function is what? X of t plus tau and dt, and this is nothing but it is a together we will be selecting one sample space is x of t, another sample space is selected